Hi everyone, Mr. Johnston here with today's lesson on classifying real numbers. So today's lesson is going to be how can I correctly classify real numbers? Now, if you had me last year, or in everyone in 7th grade, you only focused on the circles to the right, rational, integer, whole, natural. My way of teaching it for you guys to remember it is you have to remember to run in water naked. All right, so if you remember to run in water naked, you can remember the order of rational, integer, whole, and natural. Run in water naked. RIWN. Run in water naked. So, you guys have all probably heard this example that rational or the orange circle is like the United States. The pink circle are integers, which is like Texas. The blue circle, which is whole numbers, is like Fort Worth. And then the green numbers, which are natural, are North Side. So for example, the natural number of 4 4 is a natural number. However, notice how my green circle is inside of my blue circle, so that means 4 is also a whole number. Green is inside of pink, which means 4 is also an integer. And the green circle is inside the orange circle, which means 4 is also rational. Just like if you're from North Side, that means you're from Fort Worth, which means you're from Texas, which means you're from the United States. So if I asked you all of the classifications that 4 can fall into, you would have to tell me rational, integer, whole, and natural. Typically, you are asked for the most specific category. And what I mean by the most specific is how close to the center of the circle can we get? So for example, on 4, we can get all the way to the center. So if I ask the most specific on 4, you would tell me natural. Let's look at -5 as an example. So -5 is a rational number because I can write it as a fraction, and it is also an integer. However, because it is a negative, it cannot go in the whole category. So if I was to ask you the most specific category for -5, it would be integer. That's typically what you'll be asked. However, if I asked you all of the classifications, you would tell me integer and rational. Because notice how my pink integer circle is inside of my orange rational circle. So all integers are also rational. Now, just a quick review. Rational means that it is any number that can be written as a fraction. This includes but is not limited to decimals, fractions, and the tricky ones are negative decimals and fractions. So for example, if I had a -12/100ths, just because it is negative does not make it an integer. It has to be a whole number to be an integer. So -12/100ths would be rational. And the other tricky one is repeating decimals. So if I had 12/100ths repeating, it is also rational because we can write those as fractions. Any number that has the bar over it, meaning it's repeating, it can be written as a fraction. Okay, so that's the one, those are the couple of tricky ones for rational. Integer are positive and negative whole numbers, right? But it has to be what you normally think of whole numbers. Now, when we're classifying in the 4 circles, the only thing that you're going to put in whole is 0. Sometimes they will not include that natural circle in the middle. And so if that's the case, then that's where you're going to put 1, 2, 3, 4. But whenever you're asked this question on a test or a STAR test, it almost always has the 4 circles. And so the only thing you're going to put in the whole category is 0. So just remember, put 0 in the whole. And then natural is what you think of when you think of a whole number. So this is like the numbers you've been taught since kindergarten. 1, 2, 3, 4, 5, 12, 5,000. Those are the ones you put in natural. Now this year we are adding a category that is separate. So notice over here I have a box by itself off to the side. This is my irrational number category. So we now have rational and irrational, which the root IR means not. So it's basically saying these are not rational. So these are things that can not be written as a fraction. So the first one that you will recognize from last year whenever we dealt with circles is pi. And we know pi is equal to 3.1415, and then it goes on forever and ever without repeating. So any number that goes on forever without repeating is irrational. So there's three ways you will see a number that will go into the irrational category. The first one is pi. Okay? Pi always is irrational. So if you see pi, automatically put it in the irrational category. If you have a decimal that has a dot, 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 or maybe even more after it, that means that it continues going and it does not stop and it does not repeat. That goes in the irrational category. And then the last one is the square root of a non-perfect square. Okay, so the other day we talked about perfect squares. Today we're going to be using the ones that are not perfect squares. And let me show you why. So if I ask you what is the square root of 16? So what number multiplied by itself equals 16? We know that to be 4. 4 times 4 is 16. Right? If I asked you to classify 4, 4 is a natural number, which means the square root of 16, since these are equal, is also natural. However, if I asked you what is the square root of 10, okay, and I plug that into my calculator, I get 3.16228, and it's going to continue on forever. Anytime we have a square root of a non-perfect square, so that means anytime there's at least one decimal, and it's not a whole number when you do the square root, that is going to be irrational every single time. Not because it has a square root symbol, but because it's a square root of a non-perfect square. So you must remember to solve or simplify first. And then classify to get it correct.